it's load shedding. The light should go on in a little while. So you get your paper and the test for analytical geometry, and the first thing you do, instead of looking at the questions or anything, you write out your 4 formulas. Very importantly, because once you start getting into those questions, all sorts of formulas will come up. Physics formulas, formulas for depreciation in accounting. All kinds of formulas are going to come up in your brain, and you're going to be like, which one do I use? And then sometimes it's blank town, and we don't want to hit a blank and not know what to do. So we want to use kind of a process of elimination. We're going to use our distance formula, x1 minus x2, and then we have y1 minus y2. Again, I promise I do know how to write. It's just this pen that I'm getting used to. Okay, cool. So number 2 is going to be your distance formula. Remember, if they ask you, say for instance, if these 3 points form an isosceles triangle, prove that it's an isosceles triangle, distance formula. If anything to do with length or distance, then you're going to use that one. And then we have big M. Big M, like McDonald's M, is going to be midpoint. And that's trying to find the midpoint. If I've got 2 points, I want the midpoint between those 2 points. So I'm going to say, plot it almost like this. These are the x's and these are the y's. But I'm going to say that x1 plus x2, I can write, I promise, divided by 2, y1 plus y2 divided by 2, it's the average. And that's your point for x and that's your point for y. So midpoint. Okay. Then you're going to write, red is a nice color. Then you're going to write, very importantly, how do you find your gradients? This is small m, gradient of a line, maybe the line is called AB, is your change in y. Now I use the Greek uppercase letter, so it's the capital letter in Greek for delta, which looks like a triangle. Change in y, delta y. Oh, where did it go? Where did it go? Okay, it went somewhere. So let's do that again. Gradient. Oh, hello. Change in y over the change in x. And what is the change? It's when you take the y2 minus the y1. Then we have x2 over minus x1. Now, very, very, very importantly, super importantly, make sure of your signs. Make sure of your signs, because this is supposed to say y1. Oh, electricity came back on. Make sure of your signs, please, 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 please. Because if you get something like this, 4, and then my next point is a minus 2. If I haven't put this into brackets, into this bracket here, I might just by mistake at least say 4 minus 2, and I'm going to say the gradient is 2 over something, whatever it is. The gradient being 2 is very different to a minus times a minus is a plus. Very different to being 6. Very, very, very different. The gradient of 2 is maybe like this. A gradient of 6 over 1 is maybe like very, very differently looking on our graph. So make sure you put all of these into brackets. All of your values into little brackets, and make sure you put them in minus signs. And try to be as neat as possible so that you can see the minus signs clearly when you're writing. Cool. So the next one, very importantly, and that's for the gradient. The gradient tells you how the thing is moving, how it's moving over here. How the thing is moving like this, how it's moving. It tells you a lot about what's going on in your graph. So number 4, very importantly, and perpendicular. What does perpendicular mean? It means 90 degrees. So if I've got 90 degrees, I've got a 90 degree there. If I've got this line, here we go, so nice. if I've got this line and I've got this line, their m's or their gradients, this one's line gradient times this one's gradient, if they're perpendicular, is going to be equal to -1. Very importantly, super important. So if this one's gradient is 3 and they are perpendicular, what is this one's gradient going to be? Well, it's got to give you an answer of -1, right? So I've got to find something that's going to give me an answer of -1. Make it into a fraction. This helps to make it into a fraction. So if I've got something over -1, I can say my next number is going to be negative, so that I have a negative there. Then if I times them, remember we're not adding them, we're multiplying them. If I multiply 3 times -1, I get a -3. And then 1 times 3 is 3. Can you see that that is -1? So if I get given just this 3, put it over 1, do the opposite. So flip them over and put a negative. If it is a negative, don't put another negative. Let's just do a little example again. Here we go. So if I'm given 2 over 3 is my first gradient of my first line, and they say, is it perpendicular, or prove it's perpendicular, or whatever the case would be. This times something, x, and this is how you know it works. X is going to be my m. Okay, this times x is equal to -1. That's the actual sum that we're working out. This times x is -1. How do I get this? I like all these colors. How do I get this out from there? Well, it's a times. What I can do is I can actually times this by 3 over 2, so that I can get that there. Not so? And what I do to this side of the equation, I've got to do to this side. So times 3 over 2 over 2. So x is equal to -3 over 2. That's how you're going to do it algebraically. X is -3 over 2, so that m of the second line, we say m1 and m2, the m2 of the second line is going to be -3 over 2. Algebraically, we can say that. That's quite a long method of saying, it's the right method, but it's a long method of saying 2 over 3. What's the opposite of it? This is the times, by the way. What's the opposite of it? Kind of 3 over 2 equals -1. So m is going to be, m2 is going to be 3 over 2. You just swap them. And you put a minus there, so that it gives you a -1. So you can do it algebraically or not. Very importantly, remember your signs and write out these. You need to absolutely 100% write out all of these. Write out these at the top of your page. Because in it, they're going to say weird stuff to you, and you're going to be like, what the actual heck? Now, I would say only write out 4, because you know that if lines are parallel, they have the same gradients. So the gradient of AB is equal to the gradient of CD. Why? Because they're parallel. Gradients are always parallel. So if this line has got y is equal to 2x, y is equal to 2x plus c, and I've got a line parallel to that, that line is going to have a 2. Okay, so parallel means it moves in the same direction. Wherever it moves, it goes in the same direction. It's locked in like they're twinsies. Okay, cool. So after you've written out all these 4 formulas, very important formulas, even write them out 3 times before the test, so that you can remember to write them out. Do that, and let's start. So that was 10 minutes of writing out formulas. At any point, if you want to do 2-speed on YouTube so that because you know some of the stuff, great, cool, let's do it. Okay, so this is November 2015. In the diagram C, is a point on the y-axis. Cool. So that's kind of an intercept. So you know that C is going to be x is 0, and we still have to find this y value. Okay, 0 and y. So that here's A is 0 and 4. B is 4 and minus 4. Where would B? B is 4 and minus 4. And there's C, and D is minus 4, 2. Of vertices, that just means points of a parallelogram. Okay, that means that these are parallel, and these are parallel, and these are equal, and these are equal. Cool. K is a point. Cool. Also, that point is going to be 0. In X is the point 0 minus 2 and a quarter. And L is a point on AB. Cool. L is a point on AB, such that KL, where's KL? KL is parallel to CB. Now you already go, ooh, parallel. Okay, the lines gradients are the same if they're parallel. These gradients are the same as well. And this gradient, that means that this gradient is also the same as this. Also, it means that these gradients are the same as well. Cool. So, there we go. Calculate the length of diagonal DB. Now, as soon as you see lengths, that's 3 marks. Yay! Because you've written out your distance formula. You already know which one do I use. Okay, I use length. The key word here is length or distance. Length. So you're going to go dB is equal to x1 minus x2 squared plus y1 minus y2 squared. And you're going to work it out. Cool. 3 marks. Done and dusted. Calculate the coordinates of M, and just do it now as well before you even go into the test. Do it now, work it out. So here are the points of D. So here are the points of D. Calculate the length of D. B, that's a diagonal. So there's your x1, y1, x2, y2. Okay, cool. 3 points. Done and dusted. Okay. Calculate the coordinates of M, the midpoint of DB. Now you've got that midpoint. You're not going, oh, which one is it? Which one is the M? You already written out your formulas. Yay. So if M is the midpoint of DB, then you've got the length of DB. So the length, we don't even need the length. We're just going to say midpoint. Yeah. M is x1 plus x2 over 2, y1 plus y2 over 2, and it's the points here of B, which is 4 minus 4, and it's the point of D, minus 4, 2. Okay, remember when we're popping them in, make sure you pop the minus sign in as well. I will learn to use this pen better. Okay, and that is worth 3 points. 3 points just because you wrote your formulas at the beginning of the test. Okay, cool. So you can calculate the coordinates of M. Calculate the gradient of A. Where's this D? Of AD. Okay, cool. Calculate the gradient of AD. Fantastic. Literally, we're going through our formulas. Number 1 was the distance formula. And 3.1, we used the distance formula. Number 2 was the midpoint. And number 2, we use the midpoint. Number 3 is the gradient. And number 3, we use the gradient. So they're actually following our set of values, which is awesome. So the gradient is m of AD, which is equal to y1 minus, and again, do this yourself as well, over x1 minus x2. And the points are A and D. So 0, 4. And that's x1 and y1. And then we've got D, which is minus 4 and 2, which is x2, y2. And so we got change in y over change in x. So therefore we have gradients. That's another 3 points. That's already 9 points because you wrote out your formulas at the beginning of the test. Very importantly, remember your signs. Remember to put it in very specifically, all your signs. Number 4. Let's see. Prove that, this is the 4th formula. Yay. This is the 4th formula. That's so awesome. Of the formulas that we wrote down anyway. Prove that AD is perpendicular to AB. So prove it that it's perpendicular. Now you've got the gradient of AD, and you want the gradient, you got the gradient of AD, and now you want the gradient of AB. So how do you find the gradient of AB? You just found AD. How do you find AB? Well, go back to the third formula. M is equal to y1 minus y2 over x1 minus x2. Again, do the stuff beforehand. I'm not going to give you all the answers, just so that you can have some flexing those math muscles. Cool. So you're going to find the gradient of AB by popping in. A is 0, 4, and B is 4 minus 4. Remember to put that minus, please put the minus. Now we've got, how do I get this off the screen? Okay, now we've got you can say this can be x1, y1, x2, y2. Pop them in, find the gradient. If the gradient, this gradient times this gradient is equal to minus 1, put the formula of the minus 1 in, and Bob's your uncle. And now you've got 12 marks. 12 marks out of 18 marks is how much? I think it's probably about 60% as a percentage. Possibly, yeah, it's about 66%. 66% you've already got with just those 4 formulas. Just writing those 4 formulas, and we didn't have to interpret much of anything anyway. Very easy. Okay, give a reason why parallelogram ABCD is a rectangle. Okay, so what's going on with a rectangle? If I've got a parallelogram and it looks like weird and funny like this, is this 90 degrees? No. What parallelogram has a 90 degree? Well, a rectangle or a square. And I know that this is a rectangle because it's got a 90 degree. It's got, you can actually prove that the diagonals, that's more of a parallelogram. But perpendicular is 90 degrees, and you can say therefore it's a rectangle. Remember, a square is a type of parallelogram. Well, just say it's 90 degrees. So that's the answer. Okay. Determine the equation of KL in the form of y is equal to mx plus c. So gradients. Now, determine the equation KL. So let's find KL. I love gradients. Everything makes sense. Okay. So the gradient of KL is going to be the same as the gradient of this. Okay. And you can find the we did AD, the gradient of AD. So whatever you found for the gradient of AD, y is equal to mx plus c. You can pop that same gradient in, because if this is a rectangle and this is parallel to this, it means this is parallel to this. Okay, so if I've got the gradient of AD, I can pop it into my M. Okay, also, what can I also do? C. What do you know about C? What do you know about C? C is the point where x is 0. And where's x 0? At K itself. And so if it's 0 there, then it's given that this is actually C. C is going to be that y value. Okay. Let's see. So perpendicular for the M, and then C is given. C is given. Now the M should be positive because it's going up. Okay. Easy. But you got to write your formulas down. Very important. Okay, so what's next? Write down with reasons the coordinates of C. Coordinates of C. Well, C looks like it's on a diagonal. Okay, C looks like it's on a diagonal. I already know that the x is going to be 0. Okay, it's on a diagonal. I proved earlier on what the length of this diagonal was. And it wasn't this, but say for instance it was 10. Maybe it was 10. I don't know. If it was 10, I'm going to, this is the y value. Remember, because, I know. That's funny. Okay. This is the y value. This is the y value. The positive y value. And this is the negative y value. Okay? If the whole thing is 10, I'm going to take, look at this y value. Look at this y value. It's 4. I'm going to say this is 4 units. Therefore, I will learn to use this pen better. Therefore, what is this? Well, obviously it's 6 units. So you can say 10 minus 4 to give you 6. I'm not saying it is 10. I'm saying, for example, if it's 10. So the coordinates of C will definitely be a 0. Wow, the coordinates of C for 3 marks. That's cool, because you should know that it's a 0 because it's on the y-axis. Coordinates of C is 0, and then it's whatever that diagonal's length was minus this y value of 4 up. So according to my guess of 10, it'll be 0 and minus 6. Very importantly, don't just say 10 minus 4. You need to remember that this is negative y's. So this won't be 6, otherwise you're going up here somewhere. This will be minus 6. Put a minus 6 there. Please put a minus 6 there. Navigate your coordinate axis so that it's a minus. Okay. Cool. Yeah, that sounds about right. So dB is equal to AC as well. dB is equal to AC. Yeah, dB is equal to AC. And dB. Yes. Oh, I forgot to say. Diagonals of a rectangle. Diagonals, I'm trying to erase this. Diagonals of a rectangle are equal. Okay, that's why, because diagonals of a rectangle are equal, that means that what you worked out here is the same as this. Okay, that's why it's 3 marks. I was wondering why it's 3 marks. So you'd say number 1, they're equal. This one is equal to that one. Number 2, you would say 10 minus 4 is 6. and it would be -6 because it's the bottom of the y-axis. And then number 3, you would say, okay, I'm on the y-axis itself. Did this pen suddenly switch off? I think it just switched off by itself. I suppose I have to charge it or something. Number 3 would be that it's on the y-axis, therefore x is 0. Easy. Write out your formulas. If you don't, you might have lost part of this. If you don't, you might have lost part of this 66%. Okay, and you could have got 66% and 100% out of this very easily. Cool.